FastMCP 2 employs dependency injection to resolve runtime values, eliminating the need to manually pass context through every layer of your code. This mechanism allows functions to declare their dependencies via type annotations or default values, with FastMCP automatically injecting the resolved values at runtime. In the upcoming code snippet, you'll observe how a standalone utility function accesses the MCP context outside of tools, demonstrating the framework's flexibility in context management. The function retrieves the context using a dedicated dependency function and utilizes it to log a message, showcasing the seamless integration of context access in helper functions or middleware. From FastMCP server dependencies, import getContext. Async def log something message, SDR. ctx equals getContext. Await ctx.info message. This code demonstrates a utility function for standalone context access in FastMCP 2, specifically for logging operations outside of tool definitions. The logSomething function retrieves the current MCP context using getContext and uses it to log an informational message. This pattern is particularly useful for helper functions or middleware that need to interact with the MCP session but aren't directly part of the tool execution flow. The approach leverages FastMCP's dependency injection system to access the context without requiring it as a parameter. This is achieved through the getContext function, which provides the current request-scoped context. The ctx.info method is then used to send the log message back to the client. This design allows for clean separation of concerns, where logging functionality can be abstracted into reusable utility functions while still maintaining access to the MCP session's capabilities. The trade-off here is between explicitness and convenience. While this pattern makes it easy to add logging anywhere in the codebase, it does create an implicit dependency on the context being available at runtime. This is appropriate for utility functions that are designed to work within the FastMCP ecosystem, but would fail if called outside of an MCP session. The pattern is particularly valuable for cross-cutting concerns like logging, where you want consistent behavior across different parts of the application without coupling each component directly to the logging mechanism. Let's break it down line by line. From FastMCP server dependencies, import getContext. Imports the getContext function from the FastMCP server dependencies module, which provides access to the MCP context object for interacting with FastMCP server capabilities. Async def log something message, SDR. Defines an asynchronous function named logSomething that accepts a single string parameter called message. The function is declared with async, indicating it can perform non-blocking operations, though the actual implementation isn't shown in this segment. The type hint, SDR, specifies that the message parameter must be a string. ctx equals getContext. Calls getContext and assigns the returned MCP context object to the variable ctx. This provides access to the current FastMCP session's capabilities like logging, resource access, and progress reporting through the ctx variable. Await ctx.info message. Sends an informational message to the client through the MCP context's logging interface. The await keyword indicates this is an asynchronous operation that will complete when the message is successfully logged. The message variable contains the content being logged at the info level. FastMCP 2's dependency injection system enables clean, context-aware utility functions without manual parameter passing. The logSomething function demonstrates this by implicitly accessing the MCP context through getContext, then using the ctx.info method to log messages. This pattern works because FastMCP's dependency injection resolves the context at runtime, making it available anywhere in the call stack. The trade-off is clear. You gain convenience and separation of concerns, but create an implicit dependency on the context being available. This approach shines for cross-cutting concerns like logging, where you want consistent behavior without tightly coupling components to the logging mechanism. The async design ensures non-blocking operations while maintaining the framework's flexibility for both tool and standalone utility scenarios.
The context hands the server a message before the server has hands to hold it.